So we're going to look at Newton's method. Newton's method is a way that we can find our zeros or intercepts. Roots are another word for that, of an equation that's difficult. And so let's say that we have the following function and we wanted to find out where it was crossing the x-axis. So let's say that's something like this. And we want to make some estimate. So let's say that we chose over here. And so we wanted to choose some estimate. I know this is, let's say, called x of 1. And this would be my f of x of 1. And so let's look at the point here. Let's look at the equation of the tangent line. Let's look at the tangent line here. So if I drew my tangent line here at this value, I would get something that looked like the following. So I'm going to find out where this equation of the tangent line is intersecting the x-axis. And then I'm going to choose that as my next value. And I'm going to repeat the same thing. And as I repeat the same thing, I'm going to get closer and closer. And so if I wanted to find this value, let's just call this x for now. If I wanted to find that value x, well, I have a point. Our point here, right, was x of 1 and f of x of 1. My slope is equal to, at that equation of the tangent line, is equal to the derivative evaluated at x of 1. So I know that when I'm crossing this axis, though, that my y value is 0, right? So I also know that at this point right here, this point where my equation of the tangent line is crossing the x-axis, I know that this is at the point x, my y value is 0. Again, I have 2 points here. And I have the slope of that line. So I know my f prime of x of 1 is equal to my change in my y value. So f of x of 1 minus 0 all over x of 1 minus x. Okay, so let's solve for x here. So if we multiply both sides by our denominator, x of 1 minus x. So right now, we have f of x of 1 is equal to, and let's distribute our derivative. So we have f prime of x of 1 times x of 1 minus x times f prime of x of 1. So getting x by itself, we're going to subtract getting x by itself. We're going to subtract off f prime of x of 1 times x of 1. Now if we divide by our derivative, we get, or let's divide by our negative of our derivative. So let's divide every single term by negative x. No, let's divide every term by negative f prime of x of 1. There we go. Then we get that our x value here is equal to, so notice things simplify over here. Our f prime of x of 1's cancel. I have a negative and a negative, that's positive. Let's just write this one first. So I have a positive x of 1. And then over here, that first term I'm writing second on the right-hand side. So this is the same thing as minus f of x of 1 all over f prime of x of 1. So once we find that value, we want to repeat that process. And so if we go back up to our equation, and let's determine, let's say that we went back and we chose our next point to be on our graph at x, and we repeat the process where we find this equation of the tangent line. And notice that that gives us a closer estimate of where our graph is crossing the x-axis. If we keep repeating that process, we'll get closer and closer to this value where it's crossing. And we'll get a great estimate on that. Okay, so this is Newton's method right here. So if we're trying to find zeros of a polynomial, we're going to make a guess or a guesstimate estimate on where it's going to cross. And then we're going to keep on going down and reducing until we see that it's going towards some number, that it's getting closer and closer to that number. Then we can say that it has an intercept or a zero or a root, depending on what you want to call it, of that function. Let's look at an example though. So in our example, it says use Newton's method to find the negative fourth root of 2 by solving the equation x to the fourth minus 2 equals 0. Start with x of 0 equals 1, find x of 2. Okay, so looking at this, I know that my next value, x of 1, I can find by looking at the number right before this. And maybe I can write this out this way. So x of n is equal to the one right before, x of n minus 1 minus f of x of n minus 1 all over the derivative of f prime of x of n minus 1. So I notice that I need to be able to evaluate my function when x is 1, and I need to evaluate my derivative of my function at x equals 1. So maybe we should just go through and do that first. So let's find the derivative. We're finding the derivative of x to the fourth minus 2, and that is 4x cubed. So if I look at f prime of 1, this is going to give me 4 times 1 cubed. One cubed is 1, times 4 is 4. So I know what my derivative, f prime of 1, is 4. And I need to evaluate what f of 1 is. So going back into this and plugging in 1, I would have 1 to the fourth minus 2. So 1 minus 2 gives me negative 1. So by this rule, my x of 1, this is equal to my x of 0, which we were given as 1, minus f of 1. Well, f of 1 we found was -1, all over f prime of 1, which we found to be 4. So x of 1 is going to be 1 plus 1/4. So I find that x of 1, getting a common denominator. So 4/4 plus 1/4 is 5/4. So I would go through and I would do the same process. So I need to evaluate my derivative at 5/4. So let's go back in and plug it in. So I have 4 all times 5/4 quantity cubed. So this is 4. 5 cubed is 125. 4 cubed is 64. I notice I can reduce. 4 goes into 16. I'm sorry, 4 goes into 64 16 times. So this is going to give us 125 over 16. Okay, so that's our derivative. We also want to find our original function at that 5/4. So plugging into the original function, we have 5/4 raised to the 4th minus 2. So simplifying, 5 raised to the 4th power is 625, all divided by 4 raised to the 4th power, which is 256. I need a common denominator. So let's multiply that 2 by 256 over 256. And that would give us minus 512 over 256. So 625 minus 512, that gives us 113 over 256. So our x of 2 value is equal to x of 1, which is 5/4, minus f of 5/4, which is this 113 over 256, divided by our derivative evaluated at that 5/4, which we found was 125 over 16. So simplifying, I have 5/4 minus, let's multiply by the reciprocal of our denominator. So that would be 16 over 125. 16 goes into 256 evenly. Which is 16. Simplifying a little bit. So I have x of 2 is 5/4 minus 113, all divided by 16 times 125. Which is 2,000. So if I multiply 500 over 500 to that first fraction, that would be 2,500 minus 113 all over 2,000. Which is 2,387 divided by 2,000. To me, that does not look like a negative root. I'm getting this value right here. Make sure we wrote the problem right. That's because it said to start with x of 0 equal -1. The problem right before it said, let's find the positive fourth root. Let's just change that. And so our positive fourth root is going to be approximately 2,387 divided by 2,000, which gives us 1.1935. So if you go in and you look in your calculator and you look at the square root of 2, you get that is approximately 1.414. So we have an estimate. And if we continue to do that process, we would get closer and closer to that 1.414. But basically, you need the calculator on some of these after a while because they get kind of nasty.